Hi, I'm Pat from VMOD 3D Library. Today, we'll learn about how to create a new material by utilizing VMOD's ZFAB file and mask maps. Let's look at the final render. Here's today's fabric. VMOD 3D Library provides ZFAB for CLO, SBSAR for Substance 3D, PNG for most 3D software, and JSON file which include metadata information. Today, I'm going to show you how to use ZFAB and PNG's mask maps to create a completely different material from the original one. Before we begin, let me briefly explain about mask maps. VMOD 3D Library offers mask maps derived from the base color map, wherein colors are extracted and then transformed into grayscale. Mask maps offer flexibility, allowing color changes and replacements for other PBR maps with a grayscale map. In today's tutorial, we'll use mask maps as both displacement and opacity maps, not for changing colors. Mask maps have lots of different uses. We're planning to make more tutorials to show you how to get creative and find new inspiration using mask maps, so stay tuned. This is what you'll see after you download all the PNG files. You can see there are PBR texture and mask maps included in the ZFAB file. Today, we'll transform the original material into a metallic one and utilize mask maps to replace particular colored regions with an emissive material. Let's start by importing a mask map in Adobe Photoshop. Mask maps are generated by analyzing intricate color regions of the base color map, so even a small fabric segment may be divided into various distinct mask maps. Today we'll work in CLO, and it's important to achieve a noise-free result for the material we'll create. So, I'll use the Magic Wand tool to choose the black section, and then press Ctrl-Shift-I for the invert selection function to select the white part only. After that, press Ctrl-Delete to fill it with white to erase any minor noise. Now that we have a clean mask map, let's export it. Add an invert layer to generate the inverted mask map and export it. I'll name it Mask Map Invert. Let's apply the downloaded ZFAB file to an object. And then, I'll duplicate the object in the same 2D location. When copy-pasting the object, remember to align them precisely within the 2D pattern window. After that, feel free to move the copied object anywhere you want. As we have two objects in our scene, let's duplicate the material as well. I'll rename one with metallic and the other with emissive. It doesn't really matter which material you apply to each object. Now, let's apply the clean mask map that we exported from Photoshop. We'll use the original exported mask map with larger black area for emissive and the inverted mask map with larger white area for metallic. Set the opacity to RGB mode and drag and drop the mask map. When it's applied, you can see the difference between the two materials in the 2D window. Before we make detailed adjustments to the material, let's change the scale first. I'll use the Edit Texture 2D tool to scale up both materials to 300%. Open the Render window and activate Interactive Render. Wait, I think there's something wrong with the mesh. This is what happens when two objects overlap precisely each other. To fix this, I'll adjust the rendering thickness of the object with the metallic material to 1. This should resolve any meshing issues with the object. If changing the rendering thickness doesn't fix the issue, make sure the thick texture surface is applied. Now, let's change it to metallic material. Set the material type to metal. As this ZFAB file isn't a metallic fabric, a black PNG file is assigned to the metalness map. Let's remove this and check if the metalness is set to 100. Now it looks like a metallic fabric. I think it's not glossy enough. I'll raise the roughness value to make it more glossy. I also want to highlight the reflection, so I'll raise the normal map intensity to increase its reflective effect. The emissive material is much simpler. Switch the material type to light and remove all the PBR maps, except for opacity, which serves as a mask map. And then, change it to the desired color. I'll pick the green color. I think it looks a little bland, so I'll use the mask map as a displacement map. The current amount value is too low to see the difference, so I'll raise it to 8 mm. And then, lower the particle distance to 1.5 to enhance the details of the displacement. Since we're using the black and white mask map for the displacement map, we can observe some parts that break through the mesh. To address this, let's add some shift values to finish. Render it and save it as render image. Make a copy of the metallic material, change its name, and apply it to the object. Switch the material type to light, and remove all the maps except for the displacement and opacity maps. Make sure the color is black. Now, let's render it and save it as bloom image. Let's move on to post-processing with render image and bloom image. Import them all in Adobe After Effects. Create a composition from render image and add bloom image as a source. Switch the blending mode of bloom image to linear dodge. Select the bloom image and add the following 3 effects from Effects and Presets in this order: Bloom Brights, Hue Saturation, and then Levels. Adjust the blurriness in Bloom Brights. The higher the value gets, the more diffused the light will be. Then, adjust the master hue and saturation to change the bloom to your desired color. You can adjust the brightness of the bloom by changing the gamma value from Levels effect. I think it looks great. Let's wrap it up. Today, we learned about how to create a new material in CLO using VMOD's mask maps and how to create a bloom effect in Adobe After Effects. If you have any questions about today's tutorial, feel free to leave comments below. We'll be more than happy to answer. We're going to make more videos about how to use digital fabrics in various 3D software programs, so stay tuned. If you enjoyed this video, don't forget to hit the like button and subscribe our channel. See you next time.